Okay. So what is database? Okay. What do you think database is? I'm asking you guys.
The collection of data. A collection of information.
Collection of information. So what document is collection of information? This PPT is also collection of information, isn't it?
Yes. Maybe it's collection of records.
What do you mean by record? You know, this PPT can also be record, isn't it?
Yeah. Like
rows and columns.
So rows and column is not database, right? Excel is your rows and column.
Storing information in certain place.
Yeah, so PPT is also storing information, isn't it?
Mm.
collection of data, which is arranged in a systematic way.
Yeah, so PPT is also arranging in systematic way, right?
Yeah.
So yes, you know, your PPT, okay, is also kind of database, okay. But when we say database, okay, we want a system, okay, we're already talking about a system where even accessing is easier, okay. So yes, it is used for storing, and so can, you know, you can store in Word, Excel, PowerPoint, Notepad, everything you can save. But database is also useful for accessing, okay. If you have to access, okay, if you have to read a certain data, right, that's where it helps to use database system, okay. So you know, so now you know database is a software system, okay, where we store data, but at the same time, okay, what makes this different, okay, why don't we use Excel or PowerPoint, or well, we can use it, okay, but it becomes very difficult to code, very difficult to use data from. We do have mechanism to do that, okay, but it is very difficult. It is very difficult. So we came up with different system for database. Now there are different types of data. The way data is stored is different. What we use mostly nowadays is called relational database management system, okay. DBMS, database management system, Rdbms, relational database management system. So this is one type of database. You have hierarchical and different types. Those are used, but very rarely. I mean, maybe 2%, 3% systems would be like that, but 90, okay, or maybe now we are using big data more often. So maybe the RDMS would have come down. So maybe 75, 80% is still RDMS, where we store data in row and table format. So row and column. So we create column. Sorry, we create table, and each table has rows and column, right? Each column, each table will have specific information, okay, and each column will have the, like, you know, same set of values. So if I say I want to store employee data, right? So you will end up creating an employee table, okay. So when you see the table employee, by looking at the name itself, just like the use case, right? When we give a use case name, by reading the use case only, you should get 50% idea why or what it is about, right? Same thing when you say employee, table employee, you get that, oh, here this will have the employee information, employee data. And each column in the employee table will have specific information. Like if you talk about name, so it will have all name, or let's say if you say first name or last name, so you'll have first name, last name, city, mobile phone, email ID, date of joining, manager, department. So these are the information that will be stored in the table, okay, under specific column. So if you say email ID, all the values in that column will have email IDs only, right? So that's about column. When you talk about rows, okay, rows will have data belonging. So you'll have, of course, you'll have different types of data, but they belong or they represent one single information. So if I put against, Sachin Tendulkar, so you know that everything that is there in the row, for example, email ID, phone number, all those are related to the record Sachin Tendulkar, right? So it represents a single record. Rows are also called as records. Each cell is where row and column meet. Each cell will have unique values. Okay. Now again, if you talk about database system itself, there are two types of database system. We call it as OLTP, okay, which is online transaction processing. Sorry, and you have OLAP, okay, OLTP, OLAP, so online transaction processing. Okay, OL stands for online, T stands for transaction, okay, P for processing, transaction processing, and you have OLAP, online analytical processing. A is analytical. So when you talk about data warehouse, data mining, data science, data analytics, all these things we perform on OLAP, right? And for BA also, it is more on OLAP. Okay, so difference is that the OLTP database is live. So let's say when you log into Amazon needs to capture your login time, right? It needs to keep your login ID password active, okay, so that when you log in, it should be able to check immediately, right? It should be able to, log in your information. Before that, it should be able to check your password is correct or not, right? The data has to be online, and each and everything is captured live, okay? So that's called online transaction process, okay? That's OLTP, database is live, connected, and every information is saved, okay? You can read it, you can write to it. OLAP, okay, or data warehouse, data mining, analytics, uses database which is not live, okay? So it is not about, somebody logging in and capturing information. It is about information that you captured. So if you have to perform some analysis, okay, maybe let's say if you want to analyze what happened last month, for example, in May, then I don't need data from June, isn't it? So, subset of data can be given to me, okay, downloaded and given to me so that I can work on it, right? So here, this data is not live in the sense, okay, if you take the data for your analysis, and then if after taking somebody else logs in and somebody creates a new user, those things will not be reflecting on your data. Okay, so because here we are using past data to get insights. Okay, we don't really need the live data. So OLAP, analytical processing, is mostly about, okay, not only mostly, it is all about, okay, it's all about reading the data. Okay, you read the data, analyze. You will not be writing anything to it. I don't see any reason why you would be writing to OLAP database. Now, when you talk about OLTP, okay, of course, okay, so OLTP, most of the activities are more like, insert or update, where you are updating the data, okay, but you will be reading also. Let's say, for example, when you log in, right, it reads your password, matches your password with what is there in the database. That is the reading. So you'll be doing both reading and writing, editing, okay, but writing, editing will have more thing done, right? You'll be doing more of writing and editing than reading, but you'll be doing all operations. But OLAP, okay, you'll be only doing reading. Okay, you want to read the data and perform your analysis. So I'm going to talk about few things about database and how you can. There's a dummy data. Okay, not dummy. Yeah, this is a database which is online available. Okay, where you can connect and you can practice. Okay, so I'm not going to get into details. Okay, but I'm going to tell you what it is and what are the commands and how you can connect and you can practice on your own. Okay, yeah, these are about different types of database. So you have hierarchical, object oriented, object relational. Okay, but most of the databases are RDBMS, right? Relational based database system. So Rdbms history, it started in 70s by a person called Odd. He created this database at IBM. Okay, and now most of the companies that you'll hear, MySQL, okay, or Oracle database, Microsoft SQL Server, Sybase, Upright, IBM has DB2, right? All these are examples of relational database, and it is very much popular, right? That's why 75-80% market share is about RDBMS only. Okay, so now if you talk about the kind of activities that you perform on the database, okay, there are mostly 3 types of activities that we perform. One is maintaining the database. Okay, so the people who will do that kind of work, they're called database administrators, DBAs. Okay, so they don't care what is inside the database. They don't talk about the tables and data. They just talk about the structure, how to install the database, how to make sure that it's up and running, security, connectivity is there. Okay, if database becomes full, right, you need to take a backup, right? You need to backup so that people can continue to use, right? So all those responsibilities fall under database administrators. Okay, it's a different study altogether. Okay, so the database administrator, as the name suggests, you are administrator. You're managing all the database. Okay, how it should be connected, how it should be used. Okay, should it get into repair or not repair, things like that. Okay, all your responsibility. They're called as database administrators. Okay, which handles database administration. Okay, now I said 3 types, right? Second, so that is totally different. Okay, they don't even know how many tables exist and what are the different tables. Okay, they don't need to know. Then, okay, then you have database developers. Okay, their job is to create table, add, design database, right? Create table. Okay, so these guys understands the software, okay, the system, and based on that, they design the database and they are actually using creating the data to the database, right? Mostly they create. But third type role is the users. Okay, first is database administration. Second, we said the database database developers, right? Third, we are saying they are users. Okay, so here you will not create table, and that's what we will not focus on creating table. We will not focus on the aspects of creating table. We just need to know how to use it, how to connect to the database and use it, okay, based on a requirement. So when you create the database, when you say I'm creating a database, okay, you need to create database structure. Okay, now the language using which we connect to the database and work is called SQL Server. Okay, and that language is common for all the database, whether it's Microsoft or Oracle or MySQL. Okay, that piece is constant. Okay? That piece doesn't change. Okay, what changes is the database structure. Okay, and from behind the scene, all these databases are different. Okay, the way they have been developed, their logic of, okay, from front end. Okay, they all follow ANSI standard. So ANSI decides the SQL language. Okay, what features should go and things like they can develop. So these companies, they can develop more than what is given in the requirements by the ANSI. Okay, ANSI standard. So they can do more, but they cannot do less than that. Okay, if they do less, companies or people will not buy it. Okay, so of course they can do more than what is required, but they should do at least what ANSI says. Okay, so that's why if you see the query that you will write in Oracle database, same 90% chances that it will work on SQL Server or MySQL. Okay, every database tends to develop something different, something unique, which is okay, very specific to the database. Okay, since those are not ANSYS standard, Oracle develops. Why should Microsoft develop? Right? They say, okay, I don't care. MySQL also says, no, I'm working on something else. I will not. But what ANSYS says, they will all develop. Okay. So when you're when you're coding the code, when you're coding, see for business analyst, okay, or for because what we do is mostly for the OLAP. OLAP queries are personal queries, okay, because you are working on some problem, so you will create your own queries, get the answer, and that's it. Okay, rarely your queries will move from one platform to another. At max, you'll share with your colleague, and they'll also connect to the same database. So, okay, so they don't have to make any changes. Okay, so when you're developing the OLAP kind of application or BA work, you don't have to worry about ANSYS standard. Okay, but when developers are creating database, okay, the database can be anything. Okay, it can be SQL Server, MySQL, Oracle, right? These are some of the top features, top databases. So there you have to be careful because one customer might be Oracle, second customer might work on SQL Server, right? So there, okay, when they're developing the application, product development, they're very careful about the code, right? They follow as much as possible the ANSYS standard, so that the platform can be moved from one database to another without any problem. But when you are doing for your own work, doesn't really matter, right? You can choose whichever language you want to do, whether you want to work with database A or B, right? Okay. So so when I say I'm creating the database, you talk about the database structure. As I said, database structure would be different for different company. Then create tables that will hold end user data. So to create table, you have to follow ANSYS standard. So the query to the create table is same in all these databases, right? So as much as possible, you will use ANSYS standard so that query can be reused from one platform to another platform without any problem. Okay. Then when you create a database, okay, database can have multiple data, right? So when you talk about your own company, let's say you'll have finance data, HR data. You don't want finance people to see HR data. You don't want HR people to see finance data, right? So we create what is called as schema. A schema is like sub database. So it's like you have a whole house, and in whole house you have different rooms, right? Bedroom, drawing room, kitchen, bathroom, right? So same way, it's I'm giving you bad analogy, but this is for you to understand. Of course, you won't answer like this in the interview, just to understand how it works. So schema is like, so it's a database, okay, and in that you might have multiple schemas, okay. So when you create a table, you can choose which schema it should belong to. Right? Should it belong to schema 1 or schema 2? The reason we create different is that you don't want you do not want, okay, people from different, okay, so see, this is another way of managing authentication. One way is giving username password, okay, and second way is that, okay, you don't give access to, okay, so some people, let's say senior people, okay, they might have access to all the tables, right, all the schemas, but some people may not have access to all the schemas, right? As I said, finance people, you may not give access to HR. So as long as it is, they try to access, they can access another, table from another schema also, not a problem. We can access, but if you don't have permission, you won't get data. You won't be able to see any data. If you have permission only, then you will be able to see the data. So in a way, you are managing access control also using schema, okay? And tables, when you're creating the tables, you can decide which schema to put the table, okay? And authentication is about username password to connect to the database, and because if you don't connect to the database, you can't use the database at all, right? You need the username password. Okay, so that's our okay. Now, what you need to focus on, okay, is this SQL query. Okay, a little bit of SQL query is important. Okay, so when you talk about SQL query, right? So you need to create table to work with, isn't it? So when you create table, as I said, right? Maybe for practice you can do that. Okay, but very rarely you'll get a chance to create a table. Okay, table would already be created, and you are supposed to access the data from there. So this is an example of creating, table. So okay, this whole thing. Okay, so when you create a table, okay, this is a command. Okay, SQL command, which I said all database will use, right? Irrespective of whether it's Oracle or SQL Server, because these are ANSI standard. So this is the logic to create table, right? So you have to use create command. Okay, create table. Okay, you might create something else also, view or index. Okay, so that is replaced, but to create table you have to use create table, and then the name of the table that you want to create, right? If I want to create person, I would say create table person. The person became the name of the table, and then you put the bracket open and close. Okay, and then you define column name and the column type. So in this case, PNR is the column name, okay, and the type is integer. In this case, name is the column name and char 10, okay, is the type of data. So you have to define the column name and what type of data it should carry, because I told you, right, column will have same type of data. So if you talk about email address, everything will be email address, right? So you have to define the type of information that will be stored. So if you define it as integer, if you want to store number, you call it as integer, int, right? In that case, if I try to insert text data, it will not allow me to insert. Okay, that's the beauty, right? But mistake also, if you try to insert some text data, you're sure that that only numbers will be entered. In that case, user cannot enter the data or wrong data even by mistake. Okay, so this is how you would create a table, and these are the different data types that you can use. Okay, if you're defining, if you think that your column is going to have a numeric data, then you will use numeric data type. Okay, and these are the format like number, then integer, small int, decimal. Okay, if it is a character text data, if you want to store, you can use char, varchar. If you want to store date, you can use date. Then these are the null constraints. Okay, sorry, constraints. So okay, so we're still creating table. Okay, so one thing that we have learned is how to create table, right? Create table, the name of the table, bracket open and close, and within bracket open and close, you give the name of the column and data type of the column, right? Name and data type. That's all. Okay, then constraints are the restrictions that you put it on the values that a column can take. Okay, so when you say not null, it means that you cannot leave that column blank or null. So if I say employee ID, or let's say employee name is, I say not null, employee name. So I cannot, when I enter the data, okay, I can choose which columns to insert. So it's like making the column mandatory. Okay, so when you make it mandatory, okay, so you cannot leave that column blank. So not null is about not giving, right? You cannot leave that blank value there. Unique constraint. Unique constraint is given on a column where you want the column to have unique value, right? Values cannot be duplicated. And also, see, either the value will be blank or you cannot duplicate it. For example, phone number or email ID, right? When you have, when you're registering someone, right? You're saving the data like employee or whatever. So if you talk about email ID, let's say, right? Email ID, not everybody might have email ID. Fine, right? But if they have it, it will be different. Like you and I cannot have same email ID, right? It's possible that I may not have email ID. Possible. But when you talk about email ID, okay, then so every employee or every record will either have or not have. Fine. If it doesn't have, it's fine. But if it has, it is what? It should be unique. For example, email ID, right? So email ID, I may not have, but if I have, it has to be unique. It should be different than you, right? That's the use of unique. You talk about unique, but not blank, right? So it can still be blank. Then when you put not null and unique constraint together, it becomes a primary key. So when you say the column is primary key, generally you have numbers. That column cannot be left blank, at the same time cannot be cannot have duplicate values. So both, it cannot have duplicate values and it cannot have null values. We call it as primary key. Then you have default constraint. Default constraint is when the value is not provided to the value in the table. Okay, it will take the default value. So if I define default value as 5, let's say. Okay, so if you do not enter the data in that field, by default value 5 will be inserted into the data. Okay, check constraint. Okay, so it validates whether the attribute values entered, okay, meets the given condition or not. If I say this column will have value between 0 and 100 only, not more than 100, not less than 0. So when you enter a value, it checks in the background. Does it meet that given condition? If it meets, it will accept. It doesn't meet, it will show you a red cross saying that this is not what we are expecting, right? We are not ready to handle this data. Okay. This is a constraint, of course, good to know. Okay, but our main focus should be to learn how to create tables. That's what I want to show. Okay, so these are the things that you have to master a little bit. Okay, first is adding rows to the table. Okay, these are called data manipulation commands, DML. Okay, data manipulation language. Okay, DML will have DMCs. That is data manipulation command. So how to manipulate? Okay, so you have an existing database. How to manipulate the data inside the existing database? Okay, so if you want to add a new row, of course it is changed, right? So you can add a new row. You can save the table changes. Like whatever you've been working, you can save that into the table, right? Listing table rows. I want to see the data from the table. So we use select. So adding rows, new rows, we use insert command. Okay, so we'll learn about insert. Okay, saving table changes, we use something called as commit. So this is commit that we need to use. Then you have listing table rows, the select command. Okay, so select is the command when you want to list the values in the table. Okay, now if you look at the SQL, right, you probably would need minimum 1 month to learn SQL, right? And so we are not getting that into so much of detail, right? But we will need that exposure so that you know what it is, and if you require, you can learn on by yourself also, right? So that's the purpose, right? So when I say listing table, you are seeing the data in the database. Updating table rows. Updating, we use update command. Okay, so already table is there. Okay, it has some values, but you want to change some values. Okay, it might have say 5 columns. You want to change value of 1 column or 2 columns or 3 columns, right? That's updating. Then restoring table comments. Okay, so if there are comments which have been deleted, can be restored. Deleting table rows, we use delete. Okay, so you already have some values. Now that value is no longer needed in your database, so you want to delete it. Okay, so you can delete a record. Okay, using delete query, and then insert. So you have a data in some other table. You want to insert the data from some other table to your table. Okay.
Mm-hmm.
So these are the things that you need to master, okay, to be called as expert in database or database SQL command. Is it clear? I'll give you all the resources. Okay. So this is how I insert would work. So when you create a table, you'll give a name, right? So that name you have to replace here. Insert into table name and values. So see, there are 2 bullet points. The difference between first and second is that in the first case, you're not giving the columns. Like insert into table values directly. So when you say values, then you need to give value for each of the columns. So if you have created a table with 10 columns, you have to give values for all the 10 columns and in the same order. Okay, whichever column is first, you have to give the first value, second column has second value, so on. Second insert, okay, talks about that, if there are